I'm going to do the first video of a series of videos on algebra. Today I'm going to start right at the beginning. So obviously for those of you who haven't done this perhaps before, for some of you, some of the stuff at the beginning might be things you've already talked about in the past, so feel free to jump forward to the later sections if you want, or you can just kind of watch the whole thing all the way through. So I'm going to talk a little bit about the basics, the names for different things, so when I say different words and terminology, you know what I mean. And then today we're going to look at some expanding and simplifying, which are two of the very foundational skills of algebra that we're going to practice today. And there's lots of different examples, so let's get started. So let's imagine it's cold storage, it's quite expensive maybe. You're at a shop, okay, and you have a basket of shopping, and you've got, as you can see, 3 bananas and 2 apples. You take them to the till, and they say, oh, the total is $8. But let's imagine there's no price stickers on anything. You don't know the price of individual items. Well, in this example, we can see that all the apples and all the bananas are the same as each other. So we can assume that they are the same cost per banana and the same cost per apple. So we could write ourselves, first of all, at the moment we've got like a pictographic expression showing the situation. First thing we could do is try and write this as a sentence. So we could say 3 bananas, great handwriting, and 2 apples, total $8. So that would be like how we could write it in words. We could then maybe shrink that sentence down and maybe start to add in a couple of mathematical symbols. We could say 3 bananas plus 2 apples equals $8. So we're starting to make it look a bit more mathematical. But bananas and apples, we know we could, instead of saying the whole word, what we could do is instead use a little bit of algebra. We could say 3b, b for banana, plus 2a equals $8. And what I've done there is started off with picture, sentence, couple of symbols, and now we've ended up with an algebraic term. And that at the end, that is, in essence, essentially, is the foundation of algebra. We can take a very simple real-world situation. Instead of writing a whole sentence out, we can use symbols like the plus and the equals, and we can use letters like A and B, or any of the 26 letters of the alphabet, and we can change a situation into something, a mathematical algebraic expression. Didn't want to do that. We'll go to the next page. What about if you had this picture here? So I'm just going to... If we had this picture here, you can see we've got a combination of apples and bananas. Now, we know that we can use B for banana. That to be a pen. B for banana. We said we can use A for apple. But we're not going to say B, 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 A, B, A, B. It's already taking a long time. We could say, obviously we could do that if we wanted to, but that seems a bit long-winded. What we can first of all do is for each, like these 3 here, say, is you could have said, oh, instead of saying B, 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 we could have combined that together to say, well, that's 3B, isn't it? And this here at the bottom we could say is 3A, and so on. But even that seems a little bit long-winded. But what we could do instead is we can do something called combining terms. We could say we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 bananas. So we could write ourselves an expression to say we've got 9 bananas. We've got 1, 2, 3, 4, 5, 6, 7 apples. And we're combining them together. So we could take that picture and represent it with the algebraic expression 9b plus 7a. We've got 9 bananas and 7 apples. Now, what I commonly see students doing is they say, oh, well, I've got 9 bananas and 6 apples. 9 plus 7 is 16. But when you think about that, you don't have 16 bananas. You don't have 16 apples. I sometimes see students say this, oh, well, I've got 16 BA, banana apples. But we don't have 16 banana apples. We have 9 bananas and 7 apples. Different letters stay separate because they're different things. Bananas and apples, you can't squash them together. Well, you could do, but you wouldn't because that would be weird. We have 2 different fruits, bananas, apples, 9 bananas, 7 apples, and we leave it like that. Separate letters stay separate. We can also, as we know from maths, we can subtract. What about if we had 3 bananas take away 2 apples? Well, can we say if I have a basket of fruit and I have 3 bananas in my basket and I take out 2 apples, does that mean I've got 1 banana? No. 1 apple? No. 1 apple banana? No. We've just got 3 bananas and we're taking away 2 apples. So in algebra, separate letters stay separate. What about if we have a mixture like this? Well, let's see how we can write it again as an algebraic expression. We could say I've got a banana and an apple and 2 bananas and 2 apples. And we can combine those together and say, well, we've got 3 bananas and 3 apples. You can see a lot of pictures of bananas and apples, so continue to enjoy them. Now, of course, apples and bananas, we're hopefully getting to the point now where we don't need to keep me copying and pasting those pictures of bananas and apples. We can now skip the pictures and go straight to the algebra. A useful thing here is to know a few different names for a few different things. So, in this scenario, we've got different parts of what we call an algebraic expression. So the first things first, the whole thing all together we call an expression. We're expressing something like apples and bananas as a whole. And that's the whole thing, A, the 3A, and the 2B. If we were looking just at the A, we can say that A is a variable. Think of our first example when we were talking about the cost. The cost of apples can vary when you go to different places. It's not always the same price. It's not like you go to a shop in Singapore and then you go to another shop in Venezuela and apples are always the same price. They can be any price you want. Some shops in Singapore have different prices to others. Now, when we have 3A, remember, that's like 3 apples together. This 3 tells us how many we have. Okay. I'm back. So, I have 3 apples. The number that tells us how many we have is called the coefficient. Now, the A at the beginning doesn't have a coefficient written down, but you can always think of that as 1A. The coefficient is 1. There is one of them, but when there's 1 or something, we don't say, I have 1 apple, you just say I have an apple. When we put the 2 and the B together, so the whole thing, so like 2B, each part is called a term. So 3 in the 3A is the coefficient. A is, that little A there is the variable. But 2, when you put them together, they make a term. So this expression, the whole thing has 3 terms. It has A, 3A, and 2B. So that's the different names of the different parts. What about if we saw an expression like this today? Well, we can see we've got apple, 3 apples, and 2 bananas. No one says that in the real world. But you could say, well, I've got 4 apples altogether. 1 apple plus 3 apples. And then you've got 2 bananas. This process is called simplifying. Sometimes it's called collecting like terms. Like as in the things that are like each other. We put the apples together, they're like. We don't put the bananas with the apples. So our answer would be 4A and 2B if we were asked to simplify. Let's look at some other examples. Here we've got A's and B's. But we've also got some positives and negatives, so be very careful with your positives and negatives. Now, we've got 2 apples to start off with. Now, this little minus, you're thinking, oh, okay, it's 2a minus everything else, but that's not how it works with algebra. When you start off with 2a and you're collecting like terms, you don't worry about b's or c's or any other letter of the alphabet, you're only concerned with the a's. We've got a 2a here and we've got a 4a here. They are like, they are the same. But that 4a also has this plus in front of it. So that plus goes with the 4a. It's just with that 4a and nothing else. If we use a different colour, we can see we've got 5b and it's positive, so see the plus stays with the 5b. And the minus is just for the 3b. I cannot stress this enough, okay? Because this is the most common mistake students make when they simplify. They think that it's 2a minus everything else. It's not. That minus is just with the 3b, just the bit I've coloured green. The 4a has nothing to do with that negative. I'll say that one more time. The minus just goes with the 3b. Okay, it's almost like I could just take that out. Oh, I didn't want to colour it, it's that bit. Okay, everything else is positive, it's just this here. Now we can also, when we have algebraic terms, now I've coloured them in, I'm just going to copy and paste them so you can see what I'm going to do here. If we want to, we can also move them around, but as long as we keep the sign with the number. I can take this here and say, oh, I'll move that over there, let's move that over here. Let's maybe move that bit there and move that bit here. They're like little building blocks, like Lego. Now we've got the A's with the A's and the B's with the B's, and we can see 2a and 4a makes 6a, positive. Here we've got plus 5 minus 3. 5 minus 3 is 2. But it's positive 5, negative 3 makes positive 2 altogether. And that would be your answer for this question. The A's and the B's together. What about if we see some brackets? And we've seen them earlier on in this year, particularly when we're doing the negative numbers. Back to the pictures. Yay. So here I've got 3 outside a bracket, and then 3 bananas and 2 apples in the bracket. That 3 tells us how many we have of what's inside. Here we've got 3 sets of those brackets, and that looks something like this. Literally, we can see you've got 1, 2, 3 of the same thing repeated. 3 sets of 3 bananas, 3 sets of 2 apples. If we were to count these out, we could say 1, 2, 3, 4, 5, 6, 7, 8, 9 bananas, 1, 2, 3, 4, 5, 6 apples. But we want to move away from counting, so how do we do this a bit quicker? Well, let's go back to what we started with. Think of it as 3 of each. You've got 3 of the 3 bananas and 3 of the 3 apples. You've got 3 of each, 3 sets of 2 apples and 3 sets of 3 bananas. And we're multiplying those together, but we're adding the 2 different parts. 3 times 3 is 9. 3 times 2 is 6. How do we do it without pictures? In a minute we'll do that. We can also have negatives in the brackets. Got that in the next bit. This was a picture one. Again, we've got 4 of this and 4 of this. We've got 4 lots of A, and we're taking away 4 lots of 2B, 2 bananas. 4 times A is 4A. 4 times 2B, you do multiply the numbers, 4 times 2 gives you 8B. And we know we can't take an apple from a banana. Okay, next one. Now let's try and do it with just some algebraic terms. 3 and 2, 3 times 2 is 6. 3 times negative 3 is negative 9, and it's 6a, 9b. So it's just some basic multiplication, but you add letters at the end. Sorry, I keep having to blow my nose. It's very disgusting. I do apologise. Allergies. All right. Okay. What about if we've got 2 letters multiplying together. Here we've got x times 2x and x times 4. Well, the second one should be relatively straightforward. Here we've got x times 4, or 4 times x. So the last part is just going to be, I've got 4 x's. But the first part we have to be very careful. This is a common mistake I see people make. X times x equals 2x. Is that just like 3 times 3 is equal to 2 times 3? Does that make any sense? No. Two letters, or two of the same thing times together, 3 times 3, we should hopefully know is 3 squared, just like we did in the indices unit at the start of the year. So x times x is going to give us x squared. I'm going to highlight that squared. So when we multiply two of the same letters together, we get an x squared, but we also need the 2 in the front, and we're adding those together. So it's not x times x is 2x, it's x times x is x squared. I'm going to highlight that for you. Very, very, very important. Let's try another one. Yay. 2x times 3x minus 4. We do the numbers first. 2 times 3. 2 times 3 is 6. And then, let's write it again. X times x equals x squared. And this isn't just for the letter x, by the way. This is for any letter. A or B or C or D or E or F or G or H or I, and so on and so on. So 6x squared, not 2x. And then we take 2 times negative 4 is negative 8. But we also need to include the x. Now, x squared and x are two different things. It is not minus 2x. It is not minus 2x squared. It's just 6x squared minus 8x. Two different things like apples and bananas. What about if we have more than one letter? In algebra, we are great at saving time. So you're thinking x times y means x times y. We could also say x times 6z is like x times 6z. And we're adding those two things together. But in algebra, if we don't need to write the multiplication symbol. So we can say, instead of saying x times y, we just say xy. And that way we know that it's two things, two different letters that we don't know the value of, multiplied together. We've also got x times 6z. We just say we've got 6 times x and z. We add those together. So anytime you see two things, like think about it, we've seen 3x, that means 3 times x. We can see xy, that means x times y. These things become more natural with practice. Okay, any more? Oh, yay! We also might see an x squared, like we saw a minute ago, multiplied by an x. X squared times x. Well, we know that when we see this little squared, x squared means x times x. We've also got times x here. We've got 1, 2, 3 x's. So we can say it's like saying x 3. 1, 2, 3. We're going to add on 4ab times x squared. So we've got 4ab. We've also got the x squared. When you've got lots of terms like that, lots of variables, you just pop them together. 4abx squared. Nothing more to be done. We don't know what a is worth. We don't know what b is worth. We don't know what x is worth. But we do know that we're multiplying them all together. That, as you can see, they're getting a bit more complicated, but that is our answer. We've got x squared, we've got x cubed. We can't put them together because the a and the b is it's ab x squared. Okay. Oh, didn't want the screensaver then. So when they are different things, don't put them together. One more, two more. Now we've got two sets of brackets, and we're going to combine them together. We're going to expand and simplify. The question will say expand and simplify. It will say expand and simplify. So that's what we're going to do. We're going to expand, then we're going to simplify. I've color-coded them for you so you can see what we're doing. Hopefully we're getting a bit more comfortable with this now. We've got 5 lots of 3W. That's 15, 5 times 3, W's. We've got 5 times 7. 5 times 7 is 35. Notice it's just a number. We'll see what we do with that in a second. You've got positive 2. Remember the plus stays with the number. Positive 2 times 2W. 2 times 2 is 4. You've got positive 2 and negative 1. When you multiply those together, a positive and a negative makes a negative. We've got negative 2. So that's our expand. But we need to then simplify. Here we've got W, here we've got W. 15W and 4W makes 19W's altogether. Now we've got some numbers. 35 minus 2. 35 minus 2 is 33, and that is our answer. When you get a number with no letter, no variable, we call this a constant. In case you've gone from earlier, we call this a variable, and the 19 is a coefficient. Now that 19 is not a number. That 19 is how many W's I have. It's 19 W's. Yeah, whereas the 33 is just 33. So do be careful of the difference between them. Okay, last one. Let's do it one at a time. 5 times x is 5x. 5 times negative 1 is negative 5. Here we've got this negative and 3 is like negative 3. I'm going to put a little gap in to show you what I mean. Put a little gap in there. Yeah, because it's like 5x plus 1. Let's move all of that so there's a big gap in the middle so we can see. It's like two separate parts, which we're going to put together in a minute. Negative 3 times x is negative 3x. Negative 3 times positive 2 is negative 6. Then we combine those things that are the same. 5x minus 3x is only 2x. And then finally, negative 5 minus 6. Two negatives make it more negative, and that's our answer. So, we're going to pause there, and hopefully you can have a little go at doing some of this yourself, some expanding and simplifying. Just remember the apples and bananas, keep different letters separate. When you've got letters that are different, you can put them together by just putting them next to each other, like X and Y there. When you've got two of the same letters multiplied together, you make it a squared, don't make it 2x. I'm going to put not 2x. Not 2x. And when you're asked to expand and simplify when you've got more than one bracket, you do each bracket separately and you put them together and you're careful of the positives and negatives. So give this a go, see how it works. There's a few questions to try, they get harder as they go along, and we'll see how this goes.